All right, folks. Your warm up. We're talking about this young lady babysitting. She charges $7.50 an hour. I want an algebraic expression. What is an algebraic expression? Without an equal sign. What does algebraic mean? It's got to have a variable. And I tell you what variable to use, don't I? H for hours. So what would you write to represent the amount of money she's going to earn? Yep, $7.50 for every hour. Everybody all right with that? Yes? Okay. Now it says choose 5 values for the number of hours Christina can babysit. Any 5 values that you would babysit. What do you think? Come on, give me 5 values, folks. 1. It's not very interesting, but it'll work. It says create a table with H. So I'm going to make this into a table. What is going to be my label up here? This is the hours, right? What will it be telling me? Once I calculate it, what is it going to be telling me? The cost or the money that she's going to use. I think in 4th period we used M for money. So we'll go ahead and use M here for money. Notice I circled the word money and put an M underneath it. That is telling my reader that M stands for money. Okay, so go ahead and calculate. For 1 hour, 2 hours, 3 hours, 4 hours, and 5 hours. Go ahead. You should be filling in your own table. You got them for me, Trevor? Okay, start with 1 hour. $30, thank you. How do you guys feel about these numbers? Fine? Okay, I would like you to now graph them. So you're going to make yourself a graph. Which variable is my domain? Which is the input? Which is the independent? H. So instead of having X's here, folks, I have H's. What is H representing? So I'm going to label my x-axis as hours. How many hours do I need to get up to? 5. Everybody doing all right? What is my range, my output, my dependent variable? The money you make. So I'm going to put that over here on the vertical axis. M for money. How high do I need to go on the M axis? I need to get up to 37.50. I don't think I want to go by ones. 5 sound okay for everybody? All right, and now you need to plot your points. Go ahead, take your coordinates off of the table and put them onto your graph. Got them on your graph? How we doing? Are those the only 5 values you could have given me for the hours? No. So I should connect these dots. Somebody tell me why I only put an arrow on the right side and I did not put an arrow on the left side. I can't have negative hours, can I? I can't have negative money. Negative money would mean that you would be paying me to watch my kids. And that's absurd, right? Okay, so there's only an arrow over there. Now, the real question that I'm getting at here, what does this thing pass the vertical line test? Is it a function? Yes. It is a function. Okay. I want to ask a couple more follow-up questions. The domain, that's the set of all x's, correct? What are we using as x's in this problem? H for hours, correct? What types of values could you have for h? You gave me 1, 2, 3, 4, 5. Those are all whole numbers, right? Do you have to babysit for a whole hour? Or could you do halves and quarters? Yeah, so I could have fractions, right? But could I have negative? These would only be positive fractions or whole numbers, agreed? Well, there's a specific name for types of numbers that could either be fractions or whole numbers. They are called rational numbers. So the domain would be all positive rational numbers. And I'll say it again. A rational number are numbers that can be represented as fractions or decimals. And that is certainly okay for hours, isn't it? Now, if we were talking about cats, I wouldn't want a fraction of a cat. So I would not use rational numbers. Everybody all right with that? Talk to me about the range. Talk to me about the y's. What are we using for y's here? Money for m. What types of numbers could you have for money, m? What's that? They're going to have to be positive money, right? You can't earn negative money. Rational is fractions, correct? Yeah. So basically, this would be the same thing. The range would be all positive rational numbers. Okay. I think I'm ready to go down to your next problem now. Go ahead and read it. And I want you to tell me who is correct. Is Maggie correct or is Corazon correct? Who is correct? What do you think, Tyler? Who's correct? Who's correct? Why is Maggie correct? You're right. Maggie is correct. These two things are not the same. Help him out, Quentin. What do you think? The points in the table are not aligned. Let's check that. Where is negative 1, 1? Tell me where to go. Where is 0, negative 1? Where is 1, negative 3? Folks, are those points on that line? No, they're not. So are they the same function? No, they're not. So who's correct? Maggie is correct. You should be writing yourself a sentence. Maggie is correct because somebody finish that for me. Because why? The points on the table do not match the line. Wonderful. Wonderful, wonderful. All right, ready to get into our notes for today? So, folks, we are going to talk about some of the terminology today, and then we're probably going to only get through, I don't know, 2 questions today. Okay, and then we'll finish it tomorrow. Sound like a plan? Yeah? All right, so take a look. You have 2 boxes down there. Basically, I have copied and pasted your notes here for you so you didn't have to write down a whole bunch of definitions. Please notice what I have highlighted, okay? Can everybody read the left-hand box to themselves, please? Read the left-hand box to yourself, please. What 2 things are we talking about in the left-hand box? Positive and negative. Folks, if you're positive, are you above 0 or below 0? Above. So here's what I want you to do. I want you to take your pencil and I want you to make the x-axis a little bit darker. Can you do that for me? Take your pencil and make your x-axis a little bit darker. If we are above the x-axis, what are we? What does it say there? Positive. Did everybody see that? If we are below the x-axis, what are we? Negative. Pretty self-explanatory. Fair enough? Yes? Okay. Go ahead and read the right-hand box to yourself, please. When you're done reading that left or right-hand box, I want you to take your pencil and I want you to scratch out the arrows, because I don't want you to be confused by those arrows. When we read things, what direction do we read things? Left to right. So if I look at this thing from left to right, what does it start out doing? See how this is going down? Yep. Then what does it do? Then it increases and then it decreases. So please do not look at the arrows. You want to look at it as you read it from left to right. How'd we do? You make little notes on there like I did? Come on. So that's positive and negative, increasing and decreasing. If you turn to the next page, please read the left-hand box. I would like for you to circle the word extrema. What word do you see within the word extrema? What does extreme mean? What's that? Out of the park. So either really high or really low. How do we represent that on a graph? It's really low. It's called a what? So you see this portion right here? That's a minimum. It makes a valley. That's what I will call it, a valley. What if it's really high? It's a peak. It's a maximum. Peaks and valleys. Now, does that mean that this point right here is the highest it will ever get? No, that's just in that general area, that's the high point. Or in this general area over here, that's the low point. Fair enough? Yes? Okay, one more box to go. Go ahead and read that other box. This is where we get to look at the arrows. So if I say the left-hand behavior, what side of the graph am I looking at? The left side. It's not rocket science, right? Look at the left arrow. Is that thing going up or going down? So you would say the left-hand side is increasing. Fair enough? What about the right-hand side? Decreasing. You're looking at your arrows there. Again, that's not too hard. Everybody all right? Finally, I would like to write in the definitions of the x and y intercepts. Anybody want to tell me what it means to intercept? What's that? Take away, take over, definitely like an interception in football. You take it away. Give me another definition. Still football reference. What's that? When two things cross paths, think about like an intersection of roads. That's where they cross, correct? Same thing for an intercept. An x-intercept is where a graph crosses the x-axis. Where a graph crosses the x-axis. Guys, which one is the x-axis? The horizontal one. That's the x-axis. So then I'm pretty sure you probably can tell me the definition of the y-intercept. Yep. Where a graph crosses the y-axis. And which one is the y-axis? The vertical one. And today, all we're going to get to is x and y intercepts. What's up? You sure? Okay. All right, we ready to talk about these? Sure. I'm going to do 2 problems today, and that's going to be it. Sound good? Okay. Read the paragraph and look at the picture, please. We'll get to, if you open it up, there's other different ones. We'll get there. What's the first thing? Well, first of all, what are we talking about in this question? Linear and nonlinear. Okay, what's the situation here? What's going on? What are they doing? Okay, you guys still aren't reading. Height of a launched object. If I'm launching it, I'm throwing it, right? Anytime you throw anything, what shape does it make in the air? Goes up and goes down. An upside down U. These will eventually be called a parabola. Okay. Every single time you throw something, it makes a shape, period. Gonna go up and come back down. I want to know, is that graph linear or nonlinear? Now, I didn't define this for you, but you should be able to tell. What do you think, Luke? It is nonlinear. Why is it nonlinear? Yep, it's curved. It's not a line. Fair enough. I didn't need to define that for you. You pretty much figured it out. What else do I need to find? The intercepts. Now, you'll notice I have little bubbles over there for you, pointing them out to you, right? Let's do the x-intercept first. And please go ahead and put a little point down there. And can you please tell me what that ordered pair would be? Ordered pair. 8 comma what? Everybody go with 8 comma 0? Yes? Now, it also says you're supposed to interpret it. It means describe to me what it means. Now, folks, this 8 is what variable? And the 0 is what variable? And the x is the horizontal axis, correct? Guys, what are we measuring in the horizontal axis? Time in seconds, correct? So what does this represent? 8 seconds. All right, so we got the horizontal part. This is the y, isn't it? What are we measuring on the y-axis? And what does this mean? No height. So where is it? It's on the ground, isn't it? So tell me a sentence that describes 8 comma 0. After 8 seconds, the object was on the ground. Does that make sense from these numbers? Write it down, please. All right. Let's go ahead and do the y-intercept now. Go ahead and put a point on your y-intercept. Can somebody estimate what that coordinate would be? 0 what? I'm hearing 0, 18. It's an estimate. You could put 20, that's fine. You could put 17, 19, whatever you, somewhere in that ballpark. Now tell me again, what variable is this 0? And what variable is this 18? So what does this 0 mean? 0 what? Seconds. What does this 18 mean? Meters. So what does that mean, guys? Yep. It was already up 18 feet before anything happened, right? So that means it started at 18 meters. So whoever's throwing this thing, they are 18 meters high when they throw it. It starts off the ground. You will hear me refer to the y-intercept a lot as the starting point. The starting point. Everybody doing all right? Are you sure? Because I only got one more left. We're okay? All right. Go ahead and read the paragraph. Look at the picture. What's the situation here? What do you think, Dalton? Oh, perfect. He answered my first question right away for me. Tyler, you doing okay? Yeah? Okay, we're linear. How do I know it's linear? It's a straight line. Mm-hmm. Somebody describe the situation. What's going on here? That last one, we were throwing something into the air. A controlled thaw. What does it mean if I'm thawing something? From frozen to not frozen. Which means, what is the temperature doing? If we're thawing something, we're warming it up to unthaw it, aren't we? So does this line go up? Sure it does. Okay. Okay. Can you estimate and interpret the intercepts? Now you will notice I do not have those little bubbles here to show you where the intercepts are. So you need to put a dot on that graph where the x-intercept is. Where does it cross the x-axis? What's the ordered pair? Okay. Now I need to interpret it. The 1 is the x, the 0 is the y. What does this 1 for the x mean? Time. So what are we measuring time in? So this is 1 hour, right? Now how about this y of 0? What does that represent? The temperature is what? 0 degrees Celsius. Okay, so what sentence are you going to put together for me? Go ahead. At 1 hour, the temperature was 0 degrees Celsius. You guys know that for Celsius, 0 degrees is the freezing point? What is it for Fahrenheit? 32, but for Celsius, it's 0. What about boiling? What's boiling for Fahrenheit? 2 something. 212 is boiling. What's boiling in Celsius? 100. 100. Okay. All right, let's move on to the y-intercept. Now again, it's not there. Can you please put a point on your y-intercept where it crosses the y-axis this time? Don't wait for me. You do it. Right down there. Now be careful. What's that order pair? -5. Do y'all see how it goes by fives? Yeah? Goes by fives here. Is that okay? Remember, This is the x, this is the y. So what does this 0 represent? 0 what? Hours. What's this represent? Negative 5 degrees Celsius. So write me a sentence there. What does this mean? You got it. It started at negative 5 degrees Celsius, and then we thawed it, right? We warmed it up. That's what's happening here. So what if I ask you this? What's the temperature after 3 hours? What's the temperature after 3 hours? 3 hours would be 10 degrees Celsius. Make sense? How long does it take to get to 20 degrees Celsius? How long does it take to get to 20 degrees Celsius? Here's 20. Right about there. About 5 hours. You guys remember how to interpret graphs okay? You sure? Okay, so that's it for today. You will notice we have quite a few more problems we're going to do tomorrow. I would like for you to read those definitions, the boxes that we started on the front. There's 4 boxes. There's 2 on the front, 2 on the back of the first page. You guys know what I'm talking about? I want you guys to read those tonight. And then I want you to read them tomorrow during homeroom so that when we get in here tomorrow for class, we can just go. Sound like a plan? Okay. And the ones on the